Cyber security in advanced metering infrastructure is a very, very interesting subject, particularly not only interesting, it is the subject of national, international concern. Okay, right. And there are a lot of components in this AMI, as I told you. So, how to maintain them, how to operate them, O and M of AMI. Some small case studies we would like to discuss. I think probably the case study I have chosen is Andhra Pradesh itself. It is good actually. Okay, no problem. Um, and then let us understand some business models. I think this is something, although it is non-technical, it is very, very important actually to understand what is OPEX, what is CAPEX, what is SLA, all these things, we will discuss and we will conclude. So that is the uh, these are all the subject these are all the subject for the day, and then this is the overview of the presentation, and we will understand each and every aspect of this particular presentation so that comprehensively we can compare understanding on this AMI as a nutshell. Okay, benefits of AMI. OFC stands for operational benefit, financial benefit, and customer benefit. Okay, so what are the operational benefits? In fact, smart meter benefits the entire system by it benefits the entire system by what? By improving the accuracy of the meter, that is accuracy of the meter reading, okay, energy theft detection and response to power outages, while eliminating the need for on-site meter reading. This is a very, very complex phenomenon which is happening today. In the event of a meter not functional, he has to visit, make a survey, take stock of the situation, and in case, if it is a sensitive issue, he would like to carry with him the vigilance team and then find out what has happened to that. This is what is happening today. Sitting at your corporate office, you can manage all these things by a simple app, mobile app. It is possible. That is technology. Okay. We will discuss more about it. Don't worry. Financial benefits. The smart meter as a component of the advanced metering infrastructure, it brings, financial gains to the utility company. By what? By how? And by what extent? By what? That is reducing the equipment maintenance cost. Equipment maintenance cost is what? You have to maintain an equipment. In case you buy a capital intensive equipment, it has to be properly maintained, even if it is domestic, even if it is industrial. So this maintenance plays a major role actually, and it enables faster restoration of electrical service during the power outage, and also streamlines the process of billing. So this is how it is done. This is financial benefit. From the customer point of view, the smart meter benefits the customers by what? By detecting the failure of meter early, accommodating faster service restoration phenomena, and also by improving the accuracy and flexibility of billing. Further, the smart meter will allow for time-based rate option that can help customers save money and manage their energy consumptional pattern. So this OFC benefit is very important. So you must know this: operational, financial, and customer benefit. Okay, very good. Next, now we will go to the security benefit of AMI. Okay, this security benefit is very important because the cyber security is linked to this. What is happening today? I will discuss more about the cyber security. Don't worry. The AMI technology, it enables an enhanced monitoring of system resources, which mitigates potential threats on the grid by cyber terrorist network. So we'll talk more about it, and also we'll understand more, on the phenomenal thing which is happening nationally, internationally on the cyber schemes. So we will now next understand what is the net metering. Okay, why it is called net meter? Is there any other definition apart from net meter? Is it a complex phenomena? Whether this particular net metering will have an impact on the overall billing mechanism of a customer. These things are, it will arise automatically. Okay, so a billing arrangement between the utility company and a customer with a grid tied, that is grid interacted renewable energy system. Example, when 1 kWh generated by the customer has the same value as 1 kWh consumed by the customer. So this is what it is. Okay. So basically, the meter rolls back. Rolls back is a terminology for mechanical meter. Here it is not the rolling back actually. It will just have a reverse current. Okay. Basically, the meter rolls backward and forward, recording the energy flowing between a customer's renewable energy system and the utility power grid. Utility power grid is coming into picture because it is a grid interactive system. Net meter is a grid interactive system. Okay. So the utility company allows the customer to receive credit for excess energy produced. Okay. So with net metering, a customer's net excess generation is essentially donated. Without net metering, it is donated to the utility. So without net meter, a customer's net excess generation is donated to the utility company or sold. That means to say net meter is a must in the phenomena of distributed generation system, because it is an expensive thing installing the solar, the wind, biomass, whatever it, all these things will call for what? Huge initial investment. When such case is there, naturally you have to look into this on pattern of benefit, how you are gained by this, to what way you are definitely appreciated, this whole phenomena, in what way it will going to help you. So these things naturally will arise as a question. Okay, we will see further net metering for electric customers who generate their own electricity. They're called prosumers, as I told you. So the net metering allows for the flow of electricity both to and from the customer, typically through a single bidirectional meter. Okay. When a customer's generation exceeds the customer's usage, electricity from the customer flows back to the grid, offsetting electricity consumed by the customer at a different time during the same billing cycle. So this is little tricky to understand, but once you understand, I think this will have an impact, in understanding the net meter. I think this has been taken from the database of state incentives for renewable energy. Okay, this is the glossary of terms. Under that, I have captured it. Okay, so in that, the customers otherwise would have to purchase at the utilities full retail rate. You understand this? This is very, very interesting phenomenon. So when a customer's generation exceeds the customer's usage, electricity from the customer flows back to the grid, offsetting electricity consumed by the customer at the different time during the same billing cycle. So that is a very important factor, for the net metering philosophy. So in effect, the customer uses excess generation to offset electricity that the customer otherwise would have purchased at utilities full retail rate. So he will be benefited. So this is a very important phenomena, very important aspect in net metering. How net meter works? This is a very interesting question. And also The answer is also very simple. This has been taken by LinkedIn. I think you will also get this information when you become LinkedIn members. Naturally, you will be given this to understand about this particular technology also. So install solar panel on rooftop of the building. Okay, turn off lights and other electrical appliances during daytime. Right. So solar system generate power during daytime and store it in a battery network, consume the same during night. Alternatively, export the power to grid through an inverter. Okay. Power exported to power grid minus power imported from power utility is known as net metering. Okay. What is net metering? Power exported to power grid minus power imported from power utility is known as net metering. We will see the complication of it, and we will also see what may be the advantage of it. We will also see how this can be synchronized with the mains. All these things will play as a challenge. Okay, so during power export, the meter reverses, in the sense, it gives a reverse indication. There will be an indication on the net meter. Net meter is nothing but a simple meter like this only, but it will have a separate registering mechanism. In the sense, a separate LCD module is there, or the same module with different sort of name. For example, during day, positive, negative. Positive is for export, negative is for import, like that. So this gives a credit. Okay. So during the power export, meter goes back or register backward, then forward. So thereby giving a credit. Okay. So if more power is generated and exported, then power utility may pay you back at retail or wholesale rate as per the contract had with the power utility. So this contract is very important actually. So thereby, we will be calling what is this SLC, SLA, and other things that will come into picture in the net metering philosophy. How it is done, what needs to be done, how it is to be strengthened. We will see one by one. No problem, no issues. Okay. So this is how the net meter. Understand the solar net metering. You can see the left side, particularly here. The top, a solar panel on the roof of the building, as you can see here. Okay. So there is a inverter. Okay. And there is a FIT meter. FIT meter is feed-in tariff meter. Okay. So feed-in tariff means it will record the tariff of that particular thing, in the sense automatically. Okay. Feed-in tariff. So it is actually wiring. Standard meter is also there to find out whether FIT meter and standard meter, what will be the difference. Difference can be calculated, no problem. And then it is fed into the grid actually. Okay. So through the networking mechanism. So this is how we know it is a series connected FIT meter connection. That means, it is in the series system. Okay. So the parallel connection is this one actually. This is, solar panel. There is an inverter. Also there is a PPA meter. It is, the PPA is actually the power purchase, whatever is the agreement, PPA meter, standard meter, transformer, and grid. Okay. So here, the all these cases, the standard meter is assumed to be the bidirectional meter. Okay. Standard meter is a bidirectional meter. Okay. So this is not important with PPA connection, but it's very important with net metering and feed-in tariff meters. Okay. This is very important. So this is how, you have to understand. So this is net metering connection. Solar panel, inverter, wiring, house wiring, standard meter, grid interactive system. So this is how. So this is series connected, parallel connected, and this is the net metering connection. This is how it is done, in the normal philosophy. I will ask a question to all the participants here. Can you use the same smart meter as a net meter? Okay. Can you use? So you can just write down whether you can use it or not. But I will tell you the answer. you can definitely use. What is the implication? Now, the implication is very important. You see, you take the characteristics of the meter, load characteristic of the meter, when the forward current is there, and register it. And then take the reverse current characteristics. This is known as the dynamics of the meter characteristics. Okay. When you take the reverse current, what will be the actual percentage error at different set points? You find out. And then you just corroborate whether the forward energy registration, reverse energy registration is same. If it is not same, why? So this is a question to the all the participants. I will answer that question, no problem, at the end of the presentation. Very, very interesting. So normally, you assume that the forward error and the reverse error are same. For example, let us assume that he is operating at 100% IB. 100% IB. IB means basic current. If it is 5 dash 60 amps meter, 5 amps is the basic current, 60 is the continuous current. At 5 amps, if he is operating, whether the same percentage error, suppose the percentage error during the positive stroke, positive dynamics, positive flow of power is say plus 0.5, okay, and then during negative, if it is plus 0.3, okay, then 0.2% is the difference of error which should be accounted as a criteria of non-acceptance by the utility undertaking, also for the service level agreement. I think this is to be borne in mind. You can, it will definitely have raise your eyebrows, so that this phenomena is very important. In smart meter, when you take forward reading and reverse reading, there will be some small annals, okay, differences between the forward registration and the reverse registration. So this should not pose any problem for the net metering philosophy. So bear this in mind. We will proceed further. Okay, nice. So domestic net metering and net billing system. Domestic and commercial customers who generate their own electricity by renewable energy sources can be largely benefited by using this net metering philosophy. Okay, net meter has two registers. One records energy, that is imported energy, that is energy flowing from utility to customer, and the other records other register is the same LCD panel is same, it will have plus minus, okay, and the other records energy export, okay, that is energy flowing into the utility from customer, right? So under net billing arrangement, energy generated from DER, okay, is purchased by utility, distributed energy resources. Distributed energy resources is what? Your solar, etc. Okay, is purchased by utility, and the utility rises the bill on the customer for his consumptional pattern at approved tariff, after giving credit for the electricity purchased by utility at predetermined tariff. So this is another important aspect to be governed and to be honored, actually. Okay, this is what the system is. The main elements of the grid connected, grid interactive photovoltaic system. Okay, so this is the sun ray is falling on the PV panel, photovoltaic panel. Okay, and this photovoltaic panel, once it comes actually, okay, it will generate the electricity. This is DC, it is not AC. Okay, DC. Naturally, the DC is to be converted into AC if it is to be synchronized with the grid, or if it is made interactive with the grid. Therefore, this DC is to be converted through a charge controller, and it is stored in a battery management system, battery bank. Don't think it's a small thing, it's a very big thing. Okay, and then here the inverter, after inversion, okay, the conversion happens, right? And then AC, there is a breaker panel, okay, and then the meter, and then the utility. So this is how this goes actually. From here, the DC is converted into AC, and then it is it is interacted with the grid. More power you generate, okay, excess power is exported to the grid, and the grid will also import. You can import from the grid in case you have a shortage. So to balance out, this net metering philosophy is very interesting from the point of understanding how it is giving you the real benefit for the customer application. Okay, this is a net metering for a small generator. You have the source here, sunlight. Okay, maybe it is having even the windmill, and you can interact, you can intertwine them. Okay, this is the source. This is the inverter. Okay, this is the inverter inversion mechanism, and then it goes to the house. After becoming AC, it goes to the house, and here it will, the meter will record, the bidirectional meter will record, indicates energy usage, and excess energy produced is given back to the utility. And then here it is once again interactive, goes to the grid mechanism. This is how the philosophy of net metering is taking place. Okay, so here this is a grid interactive, PV, meter, grid. These are all the loads actually. So this is the net meter. Okay. Here, the solar solution for residential and commercial property. If it is a large number, you can even add, certain large power requirement, like, water pumping, lifts also, and even lighting mechanism. So this is how, loads are added actually, if the capacity is more, right? In fact, here the solar panel, charge controller, DC, battery goes to the DC, becomes AC. Here you have a solar meter and electricity board meter. So this was the day where you can connect actually together also. Here you have to monitor the data. The data, whatever, for example, this will record the consumption of the the power which you are using in the household network, right? And then this is the board meter. It will also record how much of power you are drawing and how much of power you are giving back or taking away. So this is how. And you can add different loads also. So this is a very important factor from the point of understanding the technology exercise on the net metering philosophy. Apart from net meter, you have to understand what is gross meter. Gross meter will give you the total, in the sense, solar system. Okay, this measures the energy. Okay, and then goes to the grid. Here, electricity meter. So this will give you the energy registration, right? So this is grossly it measures total gross energy it measures. Okay, so net energy, here it goes to the net meter directly. It goes to the net meter, which is grid interactive, goes to the consumer and the grid. So this is how the philosophy of net metering is being arranged. Okay, so that is about the net meter. Then we will go to the granularity of the data and security arrangements, particularly what happens, how the security is playing a major role, what will be the implication of the security. We will discuss in detail. Okay, so protecting and securely storing the data from consumer meter to data center. So also it ensures privacy and security of the main consumers. The consumer meter information is stored in a data center. The meter information in the sense, the type of the meter, rating of the meter, make of the meter, serial number of the meter, and other recording history. How, when the meter was installed, when the meter was calibrated, when the meter is due for calibration, and whether the meter satisfy your EC requirements. Okay, all this data is available. So this particular thing will give you a sort of record and register. Okay, fine. IoT and AMI security. Okay, ensuring smooth operation of distribution system by implementing proper security standards and security layers at each level of the entire AMI ecosystem, including hardware and software. Okay, did you understand this? This is very important. Okay, that means what he says is the security layers at each level of the AMI system, including hardware, in the distribution system is to be properly ensured. Okay, next. The IoT links existing operational technology and information technology to work in tandem on the data system platform. That means, data system platform is where, you generate your data and analyze that particular thing for billing purposes and also for other applications, right? Both the hardware and software of smart meter, they require security, and if any activity is correlated to failures, whether physical security or software security, it requires a very important paradigmatic change for total system security. Paradigm, that is very important. Okay, that means hardware and software of sort meter requires definitely security if any activity is correlated to either failure, okay, physical security, software security, whatever it is, right? So physical security of smart meter assets is required to check and prevent from cyber assets and vice versa. Definitely. Okay, entire AMI system has to be modernized with meter security and meter capability to remain proven from threats, attacks, and proper security layer have to be implemented in the entire chain of AMI management. That means, the security as such will play a major role in protecting the system and also in ensuring 24 bar 7 supply to the customer. Though the main job of the utility is to ensure clean energy, green energy, 24 bar 7 to the customer without any sort of preludes. So this is the most important aspect, when we look at the AMI security, right? Next, we have the IoT and AMI security continuation. So in a physical network security has adequate cyber security measures for smart meters, which are illustrated here. Number one, secure access control, accessibility, network security, network in the sense communication, hardening and logging of data logging, malicious software prevention. So this software, if it is corrupted, it is going to give you problem wherever the software is used. In the head-end system, we use software. In MDIS, we use MDMS, we use the software. In the energy meter itself, smart meter itself, we use the software. So various, today is the software world actually. Okay, device security, different devices, IoT devices. Okay, including load. Okay, device security, that is also very important. And authorization control, how you can authorize, whom you can authorize, and what he will do. These are all certain things, which needs a lot of discussion on the cyber frame, and we'll definitely talk more about it. Okay, so when you think of this, exercise as a project management, okay, so you have to consider different aspects of management, like, supply chain management, stakeholder management, which will have an impact on the overall management of the smart metering philosophy, advanced metering infrastructure as a whole, and holistic integration of these things, and to provide a necessary 24 bar 7 supply to the end user through the utility mechanism, and address all the things which are necessary to control, to protect, and to give a comprehensive solution for the management. This is what it is, right? So coming further, we have here on-field infrastructure, like, quality and services, okay, cable availability, pole availability, binder management. Yesterday, I think I talked to you about this. pre-inspection meter, timely seal issuance, deployment of adequate distribution company staff, deployment of adequate distribution staff for billing revision, for billing updation, taking over or connecting new meter, taking away the old meter, addressing the customer issue, okay, and weekly updation of the legacy data. Legacy in the sense old data, whatever is available for your application system. And of course, this was discussed yesterday, but still, this has a relevance, today's discussion also. So how you can upgrade your system, what needs to be done to authenticate it, how you can map it, what will be the automation required for the process master data synchronization. So these are all certain software infrastructure which is inbuilt into make the system a transparent system. Today, transparency pays 100% result, for your application. You have to be transparent in all aspects of your information flow, wherever it is, whoever it is. So this will solve 100% problems. And this is the main thing, even in the cyber security arrangement. Okay. So this is the cyber security. I think we will spend some time here because this is a very interesting subject. Probably it needs a lot of discussion. It needs not only discussion, it needs a lot of attention from the utility point. Okay. So these are all the smart meters. Okay. These smart meters, they have cyber security. It is as per IS 15959 part 2. Okay. And here, it has encrypted data and authenticated data. Okay. And this AES is actually the encryption, AES 128, and the GCM we call. GCM is actually, a Galois counter mode. This is one of the system scripts, available actually. Advanced encryption standard, AES. This is also an encrypted standard available, for our encryption detail on the meter mechanism, where you can get the data for your application. In the communication system, you have IPv6, that is, the Internet Protocol version 6, which is running today. Compliant network, that is IPv6 compliant network, operating in the frequency bands allocated by this GOI, Government of India. Okay. So point to point MPLS, that is, the yesterday we talked about, the MPLS system connectivity for all sites. Okay. VPN based secured tunnel network. This is where, the networking philosophy is coming for the telecommunication modes. And here, you have the cloud. This cloud is nothing but HIP, hybrid integration platform. Why it is hybrid? Because it has a mixed potential, in the sense, the HES is a server, MDM another one. So here you have the mobile app, web portal, and here you have the database and servers. This is connected actually on the VPAT, that is voluntary product accessibility template. Okay, this is where, you can have the virtual power system also. Okay. And then here, the cloud, this is nothing but a cloud actually. This is the telecommunication system. This is the smart meter. The cloud here, you use, the cloud vendor. This Stockmeti is one of the famous vendors of this cloud vendor. This is tier 3 certified, tier 1, tier 2, tier 3 certification on the data center, on the accountability and product viability. Okay. Security services, here, we have the firewall, anti-APT, etc. Okay. Cyber security, we have, the VPAT system, that is, voluntary product accessibility template, and system hardening, physical logical separation. This is how, the cyber security measures are there on the advanced metering infrastructure system. Main issues of security. Number one, say listening. Listening in there's a port for listening actually. Listening port for the VPN. Okay. Interaction planted in systems. Denial of service. Denial of service is nothing but, which is a most important factor. The service is not available to you. Inside attack. Okay. Authorized access from the consumer point. Okay. Next. AMI security issue. AMI is also important in the connectivity structure of smart meter or smart grid mechanism. So the information technology layer and also the operating technology, they are going to operate for more system reliability. and enhanced application system. So with proper cyber physical security system, it is well protected from the system vulnerability attacking. So IoT provide existing OT and IT technology to link together and work together on the data system platform, which is a simple one, very fast cloud application, has a device management, faster data transfer technology, safety, security, data latency, that means lagging, and secure for complete system operation. So this is how the AMI security issue is being talked about. So this is the NIST model of a typical smart grid, National Institute of Standardization and Testing, located in USA, doing research on the power management system as such. Okay. So here you can see the black line is electrical, the dotted line is the communication line. Here you have renewable and non-renewable integrated. Okay, this is actually what we call mixed mode generation. Okay, mixed mode, very nice. Okay, then we have the networking, transmission networking, so which is provided with PMUs, synchrophasors, WAMs, and DC-DC. All these things, are the application-oriented system in the transmission mechanism. And the substation is automated substation, where the philosophy of automation is basically done on the distribution management system as such. Okay, and you have here the market, the operation, service provider. So that means to say there are 7 domains in the NIST network. Okay, generation, transmission, distribution, and customer will have home energy. Okay, this is HAN. Okay, ban, building, and IN, industry, IIN. Okay, so this is the smart meter AMI. Okay, home area network. Okay, building area network, industrial area network, right? And then apart from these 4 electrical system, it will have market as a domain, operation as a domain, and service provider as a domain. So the 7 domains will constitute the major thrust of the NIST model in the AMI profile and smart grid profile. So this is how the smart meter is located in the advanced metering infrastructure network mechanism. So this is where the philosophy of discussion is centered now. Now you can see further. So this is very important, where the operation is taking place. Operation in the sense the central office which decides the whole philosophy of the utility management system as such. Okay, that is what it is. So we will go further and discuss more about it. So this is actually the main defense in-depth approach for cyber security. So this is, we are spending more time here to understand what is this actually. It has different things like first is anti-malware, patch management, account management, system policy, firewall and architecture, policies and procedures, physical security. One thing which is not understood here is the patch management. What is this? Patch management is the process of what? Distributing and applying updates to software. Okay. So these patches are often necessary to correct errors, also referred to as vulnerability. Okay. Or it is also known as bug. I think probably you use this terminology in your computational management. Okay. So common areas that will need patches include, the OS operating systems. If it is a Windows operating system, Linux based system. Okay. What is it? Applications and embedded systems like network equipment. Okay. So patch management is how the business picture, test and install multiple patches, set of codes in different operating systems, applications within the network to protect them from potential threats and ensure business continuity. So, this malware management is a very important aspect in the physical security arrangement of the advanced metering infrastructure. Okay. So, policies, procedure, and people will play a major role. So, this is what I thought of I should discuss with you. Very important slide which covers the whole phenomena of how right from malware to the physical security layers are there and where the protection can be accentuated. Okay. So what are the types of cyber security tools? Cyber security software can be categorized into different types, like network security monitoring tool, encryption tool, web voluntary scanning tool, network defense wireless tool, packet sniffer, okay, antivirus software, firewall, a PKI. This is nothing but public key infrastructure, right? Very important. Managed detection service, penetration testing. So these are all very important aspects. This is taken from the cyber experts, cyber tools. In fact, these cyber tools are playing major role, in the power history management, particularly with regards to the electrical equipment which you are using in the AMI infrastructure. So this is the security challenge in AMI architecture. So this is the secure socket layer. Okay, this is third party generation. Okay, third party system. We have the home area 1, 2, n. It can be n number of systems, and you have the smart meter up to n. Okay, the the communication may be Wi-Fi, Zigbee, home plug, whatever it is, maybe. Okay, here also communication is same, and this is the data concentrator. One question was asked: one data concentrator can handle how many meters? It can handle easily about 1000 meters. Absolutely no issues. In fact, I will answer that question in writing, no problem. Okay. So this is the PLC, Internet, Wi-Fi, satellite, 4G, LTE. Okay, long-term evolution. Okay, WiMAX, etc. These are all the communication system based on the satellite, and this is the utility company data center. So from third party to utility company, how the secured data is maintained in the AMI architecture is one of the most important factor to be understood, to make sure that how you assimilate things, what you need to do, how the things are synchronized with your thinking mechanism. It's a very important slide actually to make you understand how the technology is being driven through. We will go further. You understand cybersecurity. Cybersecurity is the practice of protecting system, network, program from digital attacks. Why they call digital attacks? Because the technology is digital, right? So these cyber attacks are usually aimed at accessing, changing, destroying very sensitive information, extorting money from user, or interrupting normal business procedure. Okay. So implementing effective cyber security measures is particularly a challenging task today because there are more devices than people and attackers are becoming more innovative. What is all this is about? In fact, a successful cybersecurity approach has different layers of protection spread across the computer, network, program, data that one intends to keep safe. In an organization like you, like this Telangana company, the people, the process, okay, and the technology must be complement to one another to create what? An effective defense from cyber attack. So a unified threat management system can automate integration across select security products. Cisco is one product, only quoting it actually. Okay, and accelerate the key security operation functions, detection, investigation, and remediation. So this is what the cyber security is. I think you have understood this very clear English, and also we will try to give you the practical example of this, how it is done. As I told you, to understand cybersecurity, you have people with you, they are users, process with you, organizations, they have framework, for deal with the attempted successful cyber attack. Okay, technology is essentially, it is giving organizational benefits and individuals, like, the computer security tool to protect themselves from cyber attack. Three main entities must be protected. Okay, endpoint devices like computers, smart devices and routers, networks and cloud common technology used to protect these entities include next generation firewall, domain name system DNS, filtering network, okay, malware protection system, antivirus software, and email security solution. The antivirus software is available plenty today. Norton, McAfee, so many things. Quick Heal, okay, and email security solution. That means, the email which contains valuable data is to be protected actually. Why all these things? Because your AMI contains computational network, software, hardware, and product. So that is how cyber security is playing a major role. So stop ransomware in its tracks. Okay. Malware is what? Is a type of software designed to gain unauthorized access or to cause damage to a computer. So learn more about malware protection. Like, what? Like, the secure endpoint, free trial to make sure that it is working fine. Okay. And another important aspect is social engineering. Social engineering is what? It is a tactic that adversaries use to track, you into revealing very sensitive information. They can solicit a monetary payment or gain an access to your data confidentiality. So social engineering can be combined with any of threats listed above, like, your threats, which we have listed. Okay, make you to more likely to click on links, download malware, or trust a malicious source. Okay, this is what is happening. How this COVID-19 pandemic is impacting cybersecurity worldwide. See, the COVID-19 pandemic has forced millions of professionals into remote work, that is work from home philosophy, all around the world. Okay. So in doing so, it has created a major opportunity for hacker. So according to the recent international survey from SailPoint Technology Holding, US based company, 48% of US participants said that they had been targeted with phishing email, calls, or text messages, both personally and professionally, over the course of 6 months while working from home. Additionally, more than half of Europe, Middle East, and Africa, that is EMEA country, survey responders, as well as those in Australia and New Zealand, also reported fish during pandemic with 10%. This is very important. Okay, this is 10%, notching phishing attempts at least once per week. So this is something, which is creating a mess in the history of management. Okay, how do you classify the cyber attack in the AMI? Component wise attack, protocol wise attack, topology wise attack. What is component attack? Field components like RTU, okay, remote terminal unit, okay, they are attacked through remote access. I will show you how it is, because it's very interesting, because RTU is the heart of the distribution management system. Okay, using the communication protocol available in the public domain, an intruder can reverse engineer. That means he can make, the philosophy in the reverse engineering technique of opening the product, the data acquisition protocol, and exploit them. This is protocol wise. Topology wise, network topology vulnerability is exploited. Example, DOS, that is denial of service attack, which I discussed in the beginning, right? So a remote terminal unit is a control device. I am talking about this RTU, okay, that helps the master device. Master device is a SCADA monitoring system. Communicate with the grid devices placed across different geographical location. That means it is a computational management communication engineering system. So they can be used in wide variety of electrical processes, automation, okay, where SCADA is required to monitor and control equipment. So this is how the AMI on the classification of cyber attack, component wise attack, protocol wise attack, topology wise attack. Very important to understand. We will understand what is this RTU. You can see here in the picture. This is taken from the internet. So this is RTU, okay? And then this is, the MTU, Master Terminal Unit. Number of RTUs. One Master Terminal unit can handle n number of RTUs depending upon the system design, okay? So a remote terminal unit is a microprocessor controller unit, electronic device that interfaces objects in the physical world to a distributed control system or SCADA system, okay, by transmitting telemetry data to a master system and by using messages from the master supervisory system to control, okay, connected objects. Another term that may be used for RTU is remote telecontrol unit. So RTU is a very, very important aspect in the distribution sector, okay. Component wise attack, I'm discussing this because this is a very essential thing, for understanding how the component wise in AMI is attacked, okay. So you see here, this is a very important slide actually to understand. This has been created, on animation, and you can watch it, and you just try to understand the philosophy of it, okay. Send an email with a malware here, okay. A email has been sent. Hacker sends an email with a malware. Email recipient, okay, he opens the email and the malware gets installed quietly, right? Using the information that malware gets, hacker is able to take control of the email recipient's PC, okay. You can ask a question, sir. There is a firewall. How it can travel? As I told you, the security of this thing is a weak link, and then naturally it can be crossed. Once the firewall is crossed, naturally he will have an authority to go anywhere actually. Okay, so that is where I told you the system is to be integrated with a stable security firewall and also certain measures to prove that all these software is to be protected. So that is what I informed you in the beginning, okay. So this is the first step. Next, what he does is, next, hacker performs an address resolution protocol scan. So, okay, the bug is here already, and then it has come here. It has come to the slave database where he performs an ARP scan. The ARP scan is nothing but your address resolution protocol. These are all very important terminologies, particularly with regards to your computational system employed in the MDMS system, HES system, including the testing of your smart meters in the laboratory. Okay, all the because they are all basically a computation automatic networking system, right? Next, this is fourth agenda. Fifth is important. Once the slave database is found, hacker sends an SQL executive command, that is structured query language. He writes that and he sends to the master database. There is a slave database, there is a master database, and this is operator consoles actually in the RTU mechanism, okay, on the HMI SCADA networking protocol, okay. So next, another important, I think you are now noticing everything. And what happens to in the next stage? Next stage performs another ARP scan, okay, wherein it goes and then sits in the RTU and takes control of the RTU. Once the RTU is taken care of, the whole activity will come to an end. And that is how this particular philosophy is being driven through today in the distribution sector, where this particular RTU is controlling, or malware is controlling the entire activity of the distribution management. So this is to be definitely looked into in totality to find a solution where, how, and what needs to be done is an important aspect for discussion. Okay, very nice. Next, security adoption across levels of AMI and smart meters. Okay, at the end point, meter authentication. Authentication means whether the meter is authenticated in the sense for its data, for its privacy, for its testing, for its compliance, for its standard. Okay, all these things. Meter secure. Okay, boot and provisioning. Okay, secure boot in the sense operational system. Collector secure boot and provisioning. Okay, this is another. This is from the meter for the collector. So data encryption and decryption. How the data is encrypted, how it is can be decrypted. Meter and collector event generation and routing. This is where the security adoption across levels of AMI and smart meter is happening. So it is at the network level, like secure protocol, RF mesh protection, backhaul, etc. At the edge, this is at the network level. So network level, and then at the edge level, edge in the sense at the final stage, where XML, that is extensible markup language, data sensitization, data encryption and also decryption, crypto key. Today probably maybe understanding this cryptology, the certificate management. Okay, so in fact we are discussing all the three at the data center, what it will do. Okay, so the meter access control policy management and enforcement. Okay, and then next the ESB, we call the enterprise service bus, that is the security application particularly. Okay, next application dynamic and static vulnerability scanning. Okay, next the data encryption, decryption, storage mechanism, right? Application identity access management for the vulnerability of system, security event collection, log management, okay, forensics and compliance reporting. This is how at the data center. And then building resilience in a discom cybersecurity system. Appoint a CISO, Chief Information Security Officer. I think most of the electricity board will have this. Most of the distribution company, or even whatever it is, they have this actually. And this, what he does is, his main job is to find out what are all the phishing mechanism that is happening in the security protocol. So formulation of an information security policy, specific sub policy, procedural addressing, it should be prepared for operational area. So you audit, assess cybersecurity readiness for the utility. So security assessment, at least for critical information infrastructure. Next, you have to have the risk assessment pattern and philosophy, which is very important actually. So this is the AMI security and ERP security. Okay, so this is enterprise resource planning, which is linked to the SAP mechanism. Okay, so here we have the meter, maybe RF based, GPRS based, PLC based, and this is a security. It goes to the AMI security, it goes to the collector. Okay, and DCU, HES, this is HES here, web portal, it goes to the MDMS for data, okay, management. And this ESB, this is the enterprise service bus, as I told you. Okay, this is the SSO, that is single sign on, right? And then here it goes to the utility backend system, that is utility backend system means where the data is stored and data is definitely analyzed. All these things will happen here in the backend services. Okay, so this is the ERP security and this is the AMI security. So this is how the security is very important aspect to find out what needs to be addressed for this stability operation. Scalability of AMI system, I think this is a very important message, where the work order, the enterprise system. So here we have the data management. Okay, there are of course maybe the bus may be northbound, southbound, eastbound, westbound, etc. These are all number of HES which is linked to the MDMS. And here, you have the DCUs and you have the meters actually. From here, we have to start up to the end, it goes in the hierarchical scalability of AMI structure. Challenges in implementing of AMI system. Number one, the meter installation site, meter advising data, billing communication, poor analytics, that is, real-time data availability, installation of customer care executive specialized training for handling thousands of calls and rectification of the same. You just, this is what is happening today. I think one interesting article came recently. uh, there was a panel discussion actually, and then how this Amazon company is attending to customer calls and also the rectification mechanism, how it is being done. There was a panel discussion, very interesting actually to listen and understand, which has a correlation for what I am discussing today. For example, the customer call management itself is a very very important aspect to keep him satisfied and to address all his worries, interests, and also, and more than that, to keep him happy, how best you can incorporate the best technology available with you to in the progressive manner. That is what it is. Okay. So these are all the main challenges, utility based challenges. Okay. And then here, governmental based challenges, right? Deployment issue. Okay. Here, this is the apex of the triangle. This is the wide at base of the triangle consists of utility, where the meter specification, okay, prepaid mobile application, project area, right? All these things are done. Next, meter manufacturers, certification, product category, market maturity, etc. Agency, regulation agency. That is, here, you have the program, scope, standard, bidding documentation, monitoring, parameter, service level agreement. They are the governmental agency. Once it goes to the final end at end, the peak where the management directives, meter picking up, change of process, distribution company officials availability, etc. Here, you have the uh, supply field team, okay, connectivity, prepaid deployment. All these things are coming as a sort of necessity things in the challenges. So utility based challenges, manufacturer based challenges, governmental challenges, and then here, the management challenges, particularly to keep the whole system in an integral solution which provides power and 24 bar 7 quality power supply. Okay. We will talk, think about operational maintenance. I have discussed this actually yesterday to certain extent, but definitely, we will have some small time to understand what is this actually. In fact, regular check of system log to identify the smart meter which are not communicating with AMI system. So there, you can make sure that the smart meter communication data is in line with the communication of the system. And to make sure that you have to take definitely check mechanism and incorporate this check to address the leeway in case if has any problem. Auditing of AMI system components on regular basis. Okay. Regular checkup of HES inspection. HES inspection, how the software, how the hardware and devices are being incorporated in this, and whether they are in the functional mode, non-functional mode, and you can find out those things. Regular check of MDMS, whether the data is being stored properly, whether the data is validated, whether data is cleaned, data is estimated, billing data is in correlation with what the customer is intended to do. Okay, all these things has to be finally checked up. So these are all the operation and maintenance things, which needs to be done on a proposed check way. So audit of software and regular update of software patches, inspection of logs, smart meters, identify tamper detection mechanism. Okay, these are all things which needs to be addressed by the utility management system. Okay, system consideration, like ease of deployment, manageability, outage management performance, like distribution automation. All these things are considered as a key consideration point for the implementation of the system as a whole on an integral platform. This is known as a cascaded system, right? and upgradability, remote upgradability of the firmware, right? Remote upgradability is a key requirement of AMI system. As a functionality, it evolves security requirement change. So the operator must be able to remotely upgrade the system. So this includes both network and the endpoints. The process and functionality must be considered when selecting an AMI system. The key concerns include what? Willingness to upgrade impact the several overall system performance. Will there is anything actually to do? Will an upgrade impact my overall system performance? Question. How long it will take to upgrade and take a complete comprehensive mechanism? Question. How often are upgrades changes are required? Okay. What happens when an upgrade fails? Right? Can an upgrade be stopped or ended before it is completed for the application? Okay. Is the upgrade stored locally to the device and then activated in a separate step? These are all certain very important concerns, questions which to be addressed actually when you are trying to upgrade the firmware for the operational mechanism. Okay. In the system integrated solution. Okay. Maintenance needs support of organization also. For example, an operation organization must be created to support all functions of the AMI system. Like what? Key performance metrics. Okay, like the system operator, right? This analyst, system analysts, the engineer, field engineer, project management system managers, okay, field technicians, they are all very important mechanism with which that who will have a key role to play on not only assessment of the problem but providing a some simple solution to make sure that it is operable in all conditions under the condition of duress. Okay, systematic approach. Okay, what is the consumer behavior system? The customer analysis in terms of acceptance, retention, and response using the handheld device, mobile app, etc., is an essential parameter. So, consumer loading and unloading profile, peak power timing, retention with utility are most essential to check the behavioral pattern of the load profile of the consumer. That means very important. Consumer profile is very important. Some of the important aspects of the consumer behavior: type of the consumer, retention, time based rate, social objectivity, peak load profiling, summer load data, winter load data, maximum contract demand, integration with the grid mechanism, theft issues, fraud issues, payment history, defaulted history. These are all things, which needs definitely a big thought, not only from all, but from mainly, from the decision makers. Okay. So this AMI reduction loss, I think this was discussed yesterday. I don't think we need to go into the detail. But how the electricity company are benefited by employing certain strictures, not really the AMI, because AMI has not come into picture so far, because we are showing 2018-19, and yet, of course, where this ATC loss has been reduced from say 27.34 during 2008-9 to 18-19 to 22.1 on different technology upgradations they have done, barring whatever we are discussing. But still, we have to now project what is the loss actually in 1920, 2021. So there, a drastic reduction has to come, and our aim is to go into the single digit in line with the international trends. That means, this 22.01% should come to 10%. That is the aim of the study. And that is the main mission, with which we are working today, to make sure that India becomes in line with the technology trends available internationally. So that is the main thing. So the main purpose of this actually is to provide an AMI tool, AMI mechanism, smart metering, to make sure that this comes into the single digit parameter. Okay. So this is another important aspects, which are the benefits actually, which I thought I should be in a position to discuss here. I think probably, the short term, long term, and then here, this is, the low and high impacts. What is the impact? Key benefit, like, the one time accurate billing, etc. I think this will explain the whole thing. Main benefit is to the utility, to the customer, to the society. Society is important, where they will have energy efficiency, EE, and then reduced emission. Here, I think net zero is coming into picture. Okay, and our honorable Prime Minister's attempt to make India net zero in 2070 is the question actually, and then that is possible only by employing what we call the small grid and small appliances, particularly AMI mechanism. So skilled employment, here skill set is very important. You have to definitely have skill, in each and every aspect of your discussion, what we are doing today. Okay. And here, the categorization, right? This is very important, where, we understand the technical value, low value, high value, how, the troubleshooter is done, payment system is done, customer happiness is done, etc. In the non-monetized, in the monetized, reduction of loss, SEIDI, I think I discussed this with you yesterday. Meter reading consortium, this is a very important thing actually. Okay, remote connection and disconnection on the technical parameters. Okay, from low technical value, you have to move to the high technical value in the categorization. This is very important, and that is the main purpose actually. Okay, cost versus reliability, I think this is only a graphical representation how we know the reliability, particularly the reliability of the product, is being driven through for your management system. Okay, and a small case study I have taken actually, just I will give you the information here in order to explain, the gross metering. A 2 kilowatt rooftop solar system that generates 288 kilowatt hour per month on an average, installed by a domestic consumer, has been assumed here. So the applicable tariff slab is captured in table 1 in the next page. I think I will show you. And average cost of supply at which, the consumer is compensated for export of power has been assumed as INR 5.9 per kilowatt hour. This is, I think I will show you in the slides coming. You can just go through the slide. This is from Andhra Pradesh 2018-19 for the net metering philosophy. And you can see here the energy charges. Okay, this is the consumer category. And you have the table 2, monthly import. This is in kilowatt hours. And here, Indian rupees, INR, a monthly export of solar. Okay, payment from distribution company, net payment. So this is a case study taken just to make you understand how important is net meter and what extent, this will have an impact on the social, particularly with regards to the uh, electricity utility company management, and also give customer satisfaction. Okay, so this is table 3, where, you give the, it gives the net monthly payment for a domestic consumer for net metering philosophy. Okay, so financial, of course, this we have discussed in detail. No problem. We will just understand in 5 minutes what is this SLA, what is this OPEX, what is this CAPEX, etc. in one go. Okay, service level agreement. It ensures, AMI system meet the minimum threshold of service defined against each layer. I think all the layers we have discussed. Okay, so service level agreement is established for check in process of threshold limits. So any degradation below this minimum threshold will attract penalty as per bands of service level met. So SLA category, the categorizes the penalty capping of advanced metering infrastructure service provider, that is we call AMISP. Okay, AMISP shall ensure that the computation and data collection for the purpose of penalty SLA imposed by them, right? So what is an SLA model? Okay, availability and uptime percentage, various performance benchmarks are listed, response time, this is often associated with the work of customer service, problem resolution time, usage statistics, etc. Okay, so we have to understand what is SBD. SBD stands for standard bidding document. So the standard bidding document is generally for AMI, which comprises of smart meter, head end system, meter data management, security system, okay, and other important devices contributed for this. Okay, so this smart prepaid metering in India is on boot model. We call this as boot model. Boot model is a build, finance, own, operate. So AMISP, which we discussed, it will cover end-to-end monitoring. That is, the metering of, from feeder, metering from distribution transformer, and other end consumers. So this is a very important aspect. The documentation covers smart meter specification, okay, as per the specification, right? And then HES as per the specification, modulated, okay, and then MDMS as per the specification. Communication selection is the most important factor here, and then you have to select according to what you need to do and how it is integrated in the system. So that is another important aspect to be discussed, okay. And then what are all the main benefits of AMISP? So we have to understand, infrastructure provider. Okay, this is AMISP is nothing but infrastructure provider. Utility. So capex. What is this actually? We will see. No upfront capex. TOTEX is the total actually fixed AMSP service charges. Penalty linked to the defined SLA from the utility. Technical specification and functional requirement standardization and ownership transfer cost, okay, at zero cost. So the cost involved is not much actually from the utility point. From the AMISP point, payment structure, mechanism, inspection, subcontracting, concept of meter mode. So this is where the AMISP will come into picture. From the consumer angle, consumer engagement, connection protocol, disconnection protocol, so, okay, prepayment option, portal, okay, like mobile app, data privacy, cyber security guidelines. This is a very important aspect, to understand the philosophy of the SBD AMISP. This is how the payment mechanism is working. It may be online through net banking, debit card, wallet, UPI, whatever it is. This is the payment gateway. This is the bank account, and then directly the money from customer, it goes to the bank account automatically. And if there is an excess payment, it will follow the same route and it will come back to your account. Okay, fine. So this is what it is. And then these business models must be understood actually. Number one, capex, OPEX, TOTEX. What is capex? These are purchases of major goods, services like equipments, plant, proprietary. Okay, so these are paid upfront, all at single time. That is, capex investment can be through external or internal funding and are major purchases in a project cycle. For example, PFC is the nodal agency here in the distribution management, okay, or in the power management sector, power sector. OPEX, this include cost of company which incurs for running day-to-day business operation. So these are measurement of efficiency over time. Okay. What is TOTEX? The total expenditure of project. That is, CAPEX plus OPEX will make TOTEX. So approach looks at the total cost of expenditure over the long-term operating life of the equipment and also the project. So now we have understood these SLA, TOTEX, OPEX, CAPEX, and also the other things related to this service level agreement philosophy. Okay. And then this we have self-owned arrangement model. This is one of the models actually. Here you have self-owned, right? And then capital investment, rooftop solar meter, okay, and this goes to the consumer. Here you have the energy efficiency system, okay, or the exchange system, what we call, and this is the governmental policy system, data verification, and then this here the data is managed, particularly how you can make use of these things from the utility point of view. Okay, the key incentive mechanisms are capital subsidy, you will get subsidization, okay, incentives on tax, okay, so this is a SOP actually, generation is incentive, or is wherever it is applicable actually from the point of view. So this is where the self-owned arrangement metering model is coming into picture. And this is the capex model. Pictorially, I have written actually. So this is the most common business model for solar deployment in India. In this model, the consumer purchases the solar system by making 100% through a payment upfront or financing the system open through a bank. So this is the utility grid, okay, and settlement for excess energy, building owner, solar energy, here the rooftop solar PV system, self-finance, okay. This is how the model is working fine. This is the OPEX model, how it works actually. The entire system is owned by the developer. Rooftop owners consume the electricity generated for which they pay a pre-decided tariff monthly. So this is for consumers. It is at a low cost. And then capex model where the entire system is owned by the rooftop owners. Okay. So the RESCO is what? Renewable Energy Service Company. And then here, this is the rooftop solar, this is the utility grid, and this is the building owner. Okay, unlike a solar EPC or capex proposition, wherein the consumer owns the system and invests upfront, the RESCO model is a zero investment model in which the consumer pays only the electricity generated while the solar plant is owned by the RESCO developer. Okay. So this is what it is. I think probably most of the things have come to an end actually. There are certain small things which needs to be discussed, but however, these are all once again a repetition. This is the last one, but I think probably we have to understand this, how the data flow from smart meter will to the billing system. Okay. I think this is a very important message. This is the smart meter, number one. Number two is the communication infrastructure. Number three is the head-end system. Number four is the MDMS, where this activity has happened. Number five is the integration between the HES and MDMS. Number six is the integration between the MDMS and the distribution company. Number seven is actually the discom system billing. Okay, and this is the software mechanism with which the billing is done through customer information cell. Okay, so this is how the data flow from the smart meter to the billing system is happening. The key point here is AMI system and smart meters are in fact capable of enabling prepayment. The consumer can recharge through a POS or internet using the web portal. Okay. Cybersecurity is assured for the entire system. Okay. In India, this EESL, they have taken the initiative of procurement of cycle, particularly, they have decided for GPRS communication technology as of now. Okay. I think most of the things have been covered. I think with your cooperation, we have done the whole thing, in a good exercise. The conclusion is the most benefit of net metering is to consumers. The system is easy and inexpensive. It allows homeowners, business to produce energy. Each home can potentially power 2 or 3 other homes, protects the environment and helps preserve natural energy resources. So consumers can plan their energy consumption pattern in a holistic manner. It's estimated a consumer can save an amount of rupees 600 to 2,400 per month if it generates 10 kilowatt power. A very, very phenomenal thing actually. Okay. So this is how we have now come to a end of the presentation. And if there is anything that needs to be addressed with regards to the question, I will be happy to associate with you to answer any of the question. Okay, in case. But some questions are already in the box, which I will answer it today and give it to you. Yesterday's question was also answered, and the sheet is with Senthil Kumar. I think probably he will distribute it. And this will come to you tomorrow morning. If you have any specific question, yes, no problem, no issues. You can ask or you can chat, whichever is easy for you. Right? Okay? Thank you.
Sir, the question I have received that I will share you tomorrow. Tomorrow I will share you.
No problem. Absolutely no problem. No issues. And I will also share, the materials also along with the answers. In case you have anything, you can definitely contact me. My mail ID is there. You have any doubts, about your any of the utility practices, whatever you are adopting, you can always ask me question. And you can come through LinkedIn also, where I can clarify all your questions. Okay? No issues. Okay? Thank you so much.
Any question?
Very nice of you. for having listened to me for these 2 days. And I thank this National Power Training Institute and also this Telangana Power Company for having given me this opportunity to share whatever is known to me in metering for the public use. And then I hope my presentation will carry a lot of messages to you. And in case you have anything on the presentation, you can come back to me. Thank you so much. Nice of you. Have a good day. Okay?
Thank you, sir. Thank you,
Very
sir.
nice of you.